Hi guys, so this week we are starting our first lesson on factoring. So in the past couple of weeks we've been able to take polynomials, binomials, monomials, trinomials, and we kept multiplying them together to get big long answers like this. So what factoring means is we're going to take something or like an already big polynomial like this, and we're going to try to break it down into those simpler binomials and those simpler trinomials that you end up just multiplying. So when we factor, for this lesson this week, we're factoring by the greatest common factor. So we're pulling that out of our polynomials here. So the first thing we want to check when we are factoring by the GCF, we need to see, are all the coefficients divisible by the same number? Okay, so that's our first rule. Our second rule is how many variables can we take out? Okay, so we're going to start with number 1 here. Again, our first step to see is if the coefficients are all divisible by the same number. In number 1 here, our coefficients are 32, 24, and 16. And right now, I'm not necessarily worrying about the negative signs. When I pull out my GCF, I usually pull out a positive. That way I don't have to worry about changing signs if I pull a negative out. So we know between 32, 24, and 16, they are all divisible by 8. So our GCF, our greatest common factor between those three coefficients, is 8. So I pull that out to the front. That was our first step. So right now I'm just finding what the GCF, what that greatest common factor is. So I have the coefficients all divisible by 8. Then I need to check in step 2 is how many variables I can take. So if I have 32x to the 5th, 24x to the 3rd, and 16x squared, right? This term really means I have 5 x's, right? I'm really multiplying them 5 times. This term means I only have 3, and this term means I only have 2 x's. So when I go to take out the GCF of my variables, I can only take out as many x's as these terms have to give, right? I can only take 2 x's from each term because this last term only has 2 x's to give, right? So I can't take 5 x's from each term here because these two terms don't have 5 x's to give. Same thing, I can't take 3 terms from each of 3 x's from each of these terms because this one only has 2 x's to give. So we're going with the lowest number, or the lowest exponent on the variables. So in here, we're going to pull out an x squared. So our GCF is 8x squared, but we're not done. This is not how we find our final answer, right? We pull out the GCF, we need to write what's left over when I pull out the GCF. So when I pull out the 8, right, I'm really dividing. We said, what are these coefficients divisible by? So when I pull out the 8 from 32, I'm really saying 32 divided by 8. So when I do 32 divided by 8, I'm left with a 4. Okay, and we took an x squared. We took 2 x's from these terms, right? So if I took this x and I took this x, now I'm only left with 3 x's here. So my first term becomes 4x cubed. My second term, now I'm going to take my minus sign, right? Again, I really was saying 24 divided by 8. So that's where I'm going to be left with, right? I'm going to be left with a 3 because 24 divided by 8 is 3. And again, I took 2 x's from the term, right? So I took care of this x and I took care of this x. I'm only left with 1 x here. Okay, in my last term, again, I have my minus sign, and 16 divided by 8 is going to leave me with a 2. And if I took 2 x's from this term, I took both of them, right? I don't have any left, so I'm really just leaving the 2 here. So the point of breaking this down, right, we're taking a big polynomial, we're breaking it down into something simpler, something easier to use. So when I factor out my GCF, it's really doing the opposite of the distribution property, right? I can distribute this 8 this 8x squared to every single term inside the parentheses, and I should end up getting this exact polynomial back, right? So we're doing the opposite of the distribution property. So if I distribute, right, 8x squared times 4x cubed, right, we would do 8 times 4, and then we would add the 2 exponents, right, x and then 2 plus 3. Okay, so when we were taking the GCF out, right, we divided and then we subtracted the exponents, right? So we'll get 32x to the 5th, 8x squared minus 3x, right? Now we're doing minus 8 times 3, and then x to the 2nd plus 1, right? So we'll still get the minus 24x to the 3rd. Okay, and then the last step, right, when I multiply by the 2, I have 8 times 2, and then x squared, and I get the negative 16x squared. Okay, this is why we're doing factoring, right? We're just taking it out to make it simpler, and you can see if I did it correctly and I wanted to check my work, I can do the distribution property again, and I should get the same as I started with. So let's try the next one. So on number 2, right, remember our first step are the coefficients all divisible by the same number. In this case, I have 21, 14, and 7. All of these numbers are divisible by 7, okay? They all have to be divisible by the same number in order to take the GCF out. If it comes to a case, say this number was 17 and not 7, right, then I couldn't pull a 7 out because 17 is not divisible by 7. And in that case, I wouldn't have to pull out a coefficient. I wouldn't have to pull out an actual number as a GCF. I would just worry about the variables. But in this problem, they are all divisible by 7. So I'm going to bring a 7 out to the front. The tricky part about number 2 is now that this problem has 2 variables that we have to worry about. So we're going to start first, take one variable one at a time. If I look at my m's, right, I have 3 m's to give here, right? I really have m times m times m. I have m squared here, so I have 2 m's, and then I have 1 m here. Okay, remember, we're going with what the lowest that each one can give, right? So the lowest I can take from this last term is 1m. I can't take any more, so I'm only pulling out 1m, right? I can't take any more from this term, so I can't pull any more out. Okay, so that takes care of my m's. I have my GCF for my m. Now I want to move on to the n's. I have n squared, which means n times n. I have n squared again, and then I have a single n. Again, I can't take out n squared because this one doesn't have 2 n's to give. I have to have something in common with every single term here. So I can only take out a single n. Okay, so that's my GCF. I'm still not done, okay? When it says factor by finding a greatest common factor, you still need to give me what's left over after you pull out the GCF. So let's figure that out, right? So again, we divide the coefficients. 21 divided by 7 gives me 3. Okay, and if I took one single m here, I'm left with 2 m's, right? So I have m squared, and I took a single n, so now I'm left with a single n. So that's my first term after I pulled the GCF, right? And again, you can distribute to make sure you did this correctly. And if you get this first term the same, then you know you did it correctly. If you distribute and you don't get this first term as it's written here, then you know you made an error somewhere. Okay, moving on to the second term. Again, we're dividing our coefficient. So 14 divided by 7 gives me 2. I took a single m and I took a single n. So now I'm left with just a single m and n. Okay. Then I have the minus sign. I have 7 divided by 7 gives me 1, right? And then in this case, I took away a single m, I took away a single n. So I have nothing left over here. When I pulled my GCF out, I was really pulling this exact term out. So I can't leave this blank. I'm just leaving a placeholder as 1, right? Because if I didn't have that and I went on to distribute this, I'm not going to end up with this minus 7mn at the end if I don't have this placeholder, right? Always think about your distribution. If you distribute these, you'd get the first two terms, but if this placeholder wasn't here, I'm not going to end up with that last term, which means I didn't do this problem correctly. I still need to have it, that last term here. Okay, so those are the first two types of problems. When I get down to something like number 3, on a lot of the worksheets, on a quiz or a test, you'll see that it'll then ask you to solve. It'll ask you to find the roots of this problem. So we're still going to take the same process where we're pulling out the GCF, and then I can show you how to solve this problem. So our GCF, right now I only have 2 terms. So I have 24 and I have 12. Those are both divisible by 12, okay? You're always going with the biggest number they're divisible by. Even though they're divisible by 2, 3, 6, we're taking the greatest common factor. So we're pulling out a 12, okay? We want to know how many x's we can take out, right? This one has 2 x's to give, but this term only has 1 x to give. So I can only take 1 x from these terms. So I'm going to pull out a 12x. That's my GCF. Now I need to figure out what's left over when I pull my GCF out. So I take 24 divided by 12, gives me 2, right? And again, if I had x squared, I have x times x. If I took a single x from that, I'm left with a single x, okay? And again, 12 divided by 12 is 1, right? And if I have 1x to give, and I took it away, I'm just left with a 1, right? So this is my placeholder. I have to remember to put a placeholder here so that I'm not leaving anything out. So in our notes, the very first box talked about the 0 property. Okay, what that means is if I have a times b equals 0, I have 2 options. Either a has to equal 0 or b has to equal 0, right? So what that's saying is if I had, in this case, right, if I said 0 times 7 equals 0, right, then my a equals 0, right? One of these has to be 0 in order for my answer to be 0. I could do 7 times 0 equals 0. So all it's saying is if you're multiplying 2 things together and it equals 0, one of those 2 things has to equal 0. Because you can't multiply 2 numbers together and get 0 if one of them is not 0. So we're going to take that property, we're going to apply that to this situation when we're trying to solve, right? So I have 12x in parentheses 2x minus 1 equals 0. So again, I'm taking 2 things and I'm multiplying them together to get 0, which means either this first term has to equal 0 or the second term has to equal 0, right? I have 2 options. I can say 12x has to equal 0, or I can say 2x minus 1 has to equal 0. One of those has to be true. If I wanted to solve this out, right, I would divide by 12 here. All right, I'm going to get x is equal to 0. Over here, if I wanted to solve, I would add 1. I would get 2x equals 1, and then I would divide by 2. So I would get x is equal to 1/2. So in order to find the roots of this problem, you have to factor. You have to take out your GCF, and then you're going to split them up. Either this first term has to equal 0, the second term has to equal 0, and once you do that, you just solve your equation as you normally would, right? You're solving them individually. So in order for this to be 0, either my x term has to equal 0, or my x term has to equal 1/2. That's how we find the roots. We couldn't necessarily do that to these 2 problems up above, right? Because if I set this equal to 0, I can figure out 8x squared equals 0, and it would just end up being x equals 0. But I would have a really hard time trying to solve for x when I'm setting this equal to 0. I could add 2, right? But then I get into a little bit of a sticky situation when I have the x to the third and the x here. So you'll be asked to solve for the roots of a polynomial when you have something similar to this. There's usually only 2 terms, and you'll end up with x's that have exponents of 1. Biggest thing to keep in mind, right? My 2 rules at the top. See what all the coefficients are divisible by, how many variables each term has to give up. And then it's really just doing the opposite of the distribution property. Okay, you can always go back and check your work, make sure that you did it correctly by distributing. Okay, once you distribute, you should get the very original polynomial. Okay, as always, send me an email if you guys have any questions at all.